What's going on, YouTube? It's been a while since I've made a new video, but I do have a topic that I think is sufficiently interesting about a very old and very rudimentary technology that I think is unfortunately underutilized because of the relatively high cost to build it, relatively high upfront cost, that is, to build it with our current thinking of systems design, and that's subterranean heating and cooling. I have two photos here in my title page of a place called the Rocky Mountains Permaculture Institute. I think it's the Central Rocky Mountains Permaculture Institute. This is a place that a good friend of mine has visited. I've seen a lot of their videos on YouTube. They are up in the Rocky Mountains at 8,000 feet elevation or so. They're in a climate where they regularly get to have negative 20 degrees Fahrenheit temperatures every winter, yet they are able to cultivate passion fruit, bananas, citrus, all kinds of subtropical fruit inside of their greenhouse without using fuel to heat the greenhouse because they use a subterranean heating and cooling system. Now, the way this works is pretty simple. There is a lot of thermal mass in the earth, a lot of thermal mass, and once you get to a certain depth, the earth maintains its temperature at about 55 degrees or so. So if you dig a tunnel, make a cavern, or have a cavern, and you have a way to draw in the warm, humid air outside into the cavern, the air will exchange heat with this thermally massive ground, cool down to 55 degrees, water will condense out, and then you could pump this cooled air into your house. And then, you could have a circulation. You have here in this particular photo, they've designed a heat riser in the house to draw the air and cycle the air. So the air is going to be sucked in through this underground tube, and you constantly have cool air. This is natural air conditioning. This is a very old, ancient technology, probably been around for thousands and thousands of years when people first thought of it. The problem is to implement this in the real world. The way it's generally done is you have to excavate a huge pit, dig a huge pit, line it with insulative materials, and then run hundreds of feet of 4-inch tubing, snaking it back and forth to provide enough exchange surface so that your air can properly cool itself. Now, part of this is done because you can only get so deep, so to make up for the fact that you're not able to get down really deep into the earth, you just have a much longer tube to provide more exchange. Now, one of the ways that I think we can make this technology, implement this technology way better, is if we had tunnels, really large, wide, say 14-foot wide tunnels that were really deep into the earth, say 20 or more feet below the surface of the earth. And there's a technology company, startup, headed by a very, very famous person that is working on ways to greatly decrease, by several orders of magnitude decrease, the cost of drilling these types of tunnels. Of course, that is the Boring Company. Now, the Boring Company and Elon Musk in his presentations about it, complete with the Gary the Snail and all that, has said that their goals are to make tunnel drilling so cheap, so affordable, and so widespread that underground tunnels carrying vehicles, multiple passenger vehicles like the Tesla Model X, will be able to eliminate traffic in most major cities. Now, if you get even halfway to realizing that goal, I think it would be feasible to also use these tunnels just to make subterranean heating and cooling systems. Now, if you look at it, you think about this concept, they're talking about drilling these tunnels under all the cities, and now instead of having to dig a massive pit and then snake all of this tubing back and forth, you have a relatively straightforward proposition of drilling 2 pairs of 4-inch wide tubes straight down. You can do this with a well digger. There's all kinds of technology used to make these sorts of pipes. You do 2 pipes connecting your house to the underground Boring Company tunnel. One pipe, you put an exhaust fan. Another pipe, you put an intake fan with a HEPA filter, and you've got 50 degrees, 50-degree temperature, cool, dry air coming into your house. Now, a lot of advanced physics and mathematics would have to be done to figure out the exact capacity of such a system. But given the fact that each house has at least 40 feet of 4-inch wide piping going underground to connect them to the tunnel in the first place, and the tunnels are going to be 14 feet wide, there is a lot of heat exchange capacity in this theoretical system. It wouldn't surprise me if one tunnel running underneath a neighborhood could service, you know, thousands and thousands of homes and or condos to provide really low cost, environmentally friendly subterranean heating and cooling. And it's heating and cooling because, you know, if you live in a place where it gets way below 50 degrees in temperature, like say the Central Rockies, then being able to warm the air up to 50 degrees, that's a pretty good heat gain. So, you know, it's basically this is a drawing of a larger system to serve like a pretty big building, and you see how much exchange has to go in. But if you've got a boring company tunnel underneath, connecting like all of the houses, you know, this would be pretty straightforward. And not to mention like digging holes and laying pipe versus drilling a hole straight down with a well digger. It's a lot easier to do if you're able to achieve, or if the boring company is able to achieve its original thesis of greatly reducing the cost of drilling the tunnel in question. Now, this technology is more than just a way to cool air, cool or warm air, or store or provide an underground heat exchange. It's also a way to condense water out of the atmosphere. Because if you're somewhere where it's really hot, like say India or even Southern California now, because now Southern California, Los Angeles is starting to have humid summers. It never used to be humid in the 90s, but now because of global warming, climate change, not only are summers getting hotter, but they're starting to get more humid, and that's disgusting. So, you know, when you have hot, moist air and you run it underground and it rapidly cools to, you know, 45, let's say 50 degrees, right in the middle of this range, 55 degrees, a lot of the evaporated moisture in that air will condense out, and then you'll have a reservoir of water down here. I think Google Slides is covering it up. Then you have a way to pump it up, and you've got water. In addition to producing cool, dry air, exhaust air, you've got water here at the bottom, and you got a way to pump it. Now, the mass market application for this obviously is air conditioning for houses, and it could be the first place where you'd easily do it because you're already planning to drill hundreds and hundreds of tunnels under each of these major cities. But what if you put a greenhouse on top? And unlike houses where you know the how humid it gets to be in a house will be a function of how humid it is in that climate, within a greenhouse you've got a climate inside there where it's regularly going to be 95 to maybe even 100% relative humidity. And that's humidity that you have to vent, because if you allow the humidity to stay that high in a greenhouse, you're going to have mold and disease problems. Now, in agriculture, we figured out ways to prevent losses of water due to deep percolation. There's a lot of calculations that are involved in that so that you don't overwater and the water escapes your root zone. But the main way you can lose water in an agricultural system is through evapotranspiration. That is the action of the plants sweating. And the hotter it is, the more the plants sweat. And also, the faster the plants are growing, the more they sweat, because the main way the plants have of uptaking nutrients from their soil is they uptake water, and the water has dissolved nutrients inside of it. So if you want plants to grow really fast, you want them to sweat a lot. Now, if you were to put this whole system, subterranean heating and cooling system, and then collect the water and pump the water up to irrigate this greenhouse, you've basically achieved the holy grail of water efficiency in agriculture, because now you've captured all of the water that the plants sweat out, and you've captured it underground, and you're reusing it to rewater your plants. Now the only water loss you would have in this system is the total water content of your head of lettuce. And the total water content of the head of lettuce when you harvest it and you pull it out is pretty negligible compared to the total amount of water that that lettuce sweated up during its 50 or 60-day life cycle. And this is pretty remarkable given that water scarcity is an increasing problem that we will have uh, as climate change gets to be more out of control, and we have to figure out more ways to feed our population, which will likely peak at 10.5 billion in by 2050. So, here's another drawing of just how this would work. You got hot, moist air going in, it dissipates, a lot of the moisture comes out, cool, drier air comes up. Now, in a lot of the uh, more simplified systems, people building these passive solar greenhouses, you would achieve this because you're only burying your pipes 2 or 3 feet below the surface. So all the water comes out of your pipe, it already goes into the root zone of your plants. Now, if you're doing this with a boring company tunnel, all that water is going to be in a reservoir 20 feet below, and then you have to pump it up. Now, this fully enclosed system, uh, you know, it's like you've created the water cycle in a bottle, and this is really close to having a garden in a bottle. And having a garden in a bottle is going to be very important in a place that Elon Musk is really trying to go to. That's Mars. So here's a photo Teslarati doctored up, where a lot of people have speculated about the usage of the Boring Company technology on Mars with SpaceX to drill tunnels in Mars, because Mars has so much radiation that we're going to need to drill tunnels to live in. But using this sort of agriculture, this integrated agriculture where you have an ag dome above ground and you've got these boring company tunnels below ground, this is going to be essential for colonizing Mars. This is how the Boring Company really fits into colonizing Mars and producing food on Mars. Because when you drill these tunnels, you can grow mushrooms in them. I mean, you think about it, you have a fully sealed system, a garden in a bottle. What's going to happen is your air in your dome will get hot and moist, humid, and will also be very rich in oxygen. So in order to use up that oxygen and replenish the CO2 for your plants to grow, you're going to need mushrooms. And you could grow mushrooms in the tunnels underground. So to recap how this whole system would work is you've got your dome here. You could grow mangoes and chirimoyas in here because you're Martians. Why would you settle for any less? You would have just stayed on Earth if you would. And you've got your hot, humid air at the top of your dome. And you have this heat riser. And you got your intake fan here. So your intake fan takes up all this hot, humid, oxygen-rich air, and then it travels here 20 or feet more underground through this tube. And as it travels through here, it cools to 55 degrees. A whole lot of water condenses out. The water goes into your subterranean pond here. Your subterranean pond has a pump to pump that water back up to irrigate your plants. And then you've also got your tubes here where the cold 55-degree air rises back up, and you've got cool, dry air for your plants up here. And then down here in your 55-degree tunnel, it's a perfect temperature for growing shiitake mushrooms. And this is all completely sealed to the environment. You've got your orange Martian sun, and this is how you would, this is like an ideal agricultural system for growing things on Mars with minimal water loss and minimal outside air exchange, minimal loss of air to the outside environment. Going to be obviously be very important when you're growing things on Mars. I mean, you could do this asteroids, you could do this anywhere where you're trying to colonize space. But for the purposes of conserving resources here on Earth, you can do this on Earth. And this is a use case for the Boring Company technology that I haven't seen anyone really theorize about. Obviously, it's pretty far into the future. They have to achieve their main goal of greatly reducing the costs of drilling tunnels and such. But I think it's so compelling because this is a way that the Boring Company here on Earth can basically become a utility company that delivers heating and cooling, air conditioning, dehumidification, and produces water. And this is very interesting technology. I'd like to see what you guys think of this theory, this prospect, and any of you guys who know a bit more on the physics of it might do some calculations to see really what the yield would be, how much cooling you could get out of a subterranean tunnel, out of a Boring Company tunnel, and how much you know, how much exchange there would be. Anyway, this is one of my technology ideas. I hope you've enjoyed this concept. Peace.